Hi, I'm Dr. Robert Cohen. In this video, I'm going to show you how you can solve direct and inverse variation problems on the SAT and ACT. This is the equation for direct variation. You want to memorize this. What this basically is telling you is that, let's say we have any two numbers, we'll call them x and y. This is saying that basically as x gets bigger, y is also going to get bigger by a set amount, and as y gets bigger, x is going to get bigger by a set amount. So k is a constant. So it's this fixed amount, and it doesn't change. So there'll always be one k value in a direct variation problem. K could be 3, for instance. So if y is 2, 2 times 3, x is 6, and then if y is 3, x is 9. There's another way we can write the direct variation equation, and this other way makes it a little bit easier to see what's happening in this type of relationship. So what we can do is, let's say we divide both sides of this equation by y. The y cancels out on the right side, so we have k on the right side, and on the left we get x divided by y. So this is saying that x divided by y equals k. Let's say k equals 3. So we could say x divided by y equals 3 divided by 1. So what does that mean? That means that x is always going to be 3 times the size of y. X and y relate in a 3-to-1 ratio. X is always 3 times the size of y is always 1/3 the size of x. So as each one gets bigger, the other one gets bigger, they just have to stay in this ratio of 3 to 1. So that's what the constant's doing. Okay, so, and here's an example. If x and y, the constant is 3, so again, a 3-to-1 ratio. And let's say y is 4, what would x be? Well, x is going to be, remember x is 3 times y, so if y is 4, x is 3 times 4, or 12. And you can see 12 to 4 is a 3-to-1 ratio. Okay, now, let's look at a problem. What's this going to look like on the SAT or ACT? Well, they're usually going to give you a set of two numbers, an x and a y value, and another x and y value. And they'll tell you what 3 of the values are, and you have to solve for the 4th value. So the long way to do this would be to use our initial equation, and to use it once with the two numbers we know, the two x and y values we know, to solve for k. So I do that. I plug in x is 3, I plug in y is 2, I divide both sides by 2, I end up with 3/2 equals k. So now I know that my equation is x equals y times 3/2. 3/2 is k. So now I can take the second set of numbers, plug them in, and solve for y. So 4 equals y times k, which is 3/2. And now I just get rid of 3/2 by multiplying each side by 2/3. Do some algebra, you get 8/3 equals y. So now the second y is going to be 8/3. Okay, so fair enough. But there's a much quicker way to solve this type of problem without having to set up two separate equations. It's important to know this formula and to understand how direct variation works, and you might find yourself wanting to use this form of the formula in certain problems. But in most problems where you're given the set of two numbers, the quickest way to solve a direct variation problem is to use this setup. x1 is to y1 as x2 is to y2. So, this would be x1, this would be y1, and then our second set of numbers, x2, and this is y2. So, because remember, we're saying x1 relates to y1 in some specific ratio, like 3-to-1, something like that. So we can just set up a direct ratio. We can say x1 is to y1 is 3 is to 2, and x2 to y2 has to be in the same ratio. If x2 is 4, then what would y2 be? 3 is to 2 as 4 is to what? Now you would just cross multiply and solve. And so I cross multiply, I get 2 times 4 is 8, that equals 3 times y2, divide both sides by 3, y2 equals 8/3. So a really quick way to solve this type of a direct variation problem is to use my x1 is to y1 as x2 is to y2 formula. That said, definitely remember this form of the equation, and keep in mind what's really happening and how this type of relationship works. Okay, so now let's talk about inverse variation, and it's a lot like it sounds like. You might guess after having, since we've just done direct variation, this is the inverse, this is the opposite of that. Two numbers vary inversely. It means as the one gets bigger, the other gets smaller, or of course as vice versa, the one gets smaller, the other is going to get bigger. So here's the equation to memorize of representing inverse variation. It looks a lot like the equation for direct variation. We've just moved some things around. Instead of x being equal to y times k, x is now equal to k divided by y. Remember, k is a fixed constant. If two numbers are inversely related, there will be one fixed k, it doesn't change, that's going to relate the two of them to each other. And we can see how this works, how if one gets bigger, the other gets smaller. We can see that just by thinking about some numbers. Let's say k is 10, so that doesn't change. If y is 1, x is 10. What happens if y gets bigger, y is 2? Well then 10 divided by 2, x is 5. X gets smaller. As y gets bigger, x gets smaller, and vice versa. So it's just the opposite of direct variation. Now another way to see this is to divide both sides of the equation by y. Our y's are going to cancel out, and what we're going to end up with is, x times y equals k, equals some fixed number like 10. So, if x gets bigger, y has to get smaller, because they have to yield the same product every time you multiply them. So what's a problem going to look like on the SAT or ACT? Well, it's going to look a lot like a direct variation problem. You'll have two sets of numbers. The first will be an x and y value, and then you'll have another second set of x and y values. So, you could just use the initial equation, plug in the first x and y points to solve for k, then set up a new equation, plug in your x, plug in the k, and solve for y. But there's a quicker way to do it, and the quick way to do this is just to say, remember we saw that x and y have to equal some number every time. So the first x and y, when you multiply them together, they have to equal the same number you get when you multiply the second x and y, assuming all these x's and y's are inversely related by the same amount. So, which they would be in a problem. So we just have to plug our numbers in. X1 is 3, y1 is 5. That's going to have to be equal to x2, 8 times y2. And now it's just a quick algebraic problem to solve. 3 times 5 is 15, 8 times y2, 8y2. I divide both sides by 8, and I get y2 equals 15 eighths. So again, memorize both these formulas. You might need to use or recognize this formula on a particular problem, but most of the time you'll be given two sets of numbers, and you can simply use this setup to solve for the fourth number very quickly. If you found this video helpful, please like it, share it, or subscribe to the channel, all of which will help me reach more people looking for this type of information. Thanks.